Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. To get worry-free releases, download GoCD, the open-source continuous delivery server built by ThoughtWorks. You can use their pipeline modeling and value stream map to build, control, and monitor every step from commit to deployment in one place. And with their new Kubernetes integration, it's even easier to deploy and scale your build agents. Go to podcastinit.com/GoCD to learn more about their professional support services and enterprise add-ons. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host as usual is Tobias Macey, and today I'm interviewing Rebecca Bilbro and Benjamin Bengfort about Yellowbrick, a scikit extension to use visualizations for assisting with model selection in your data science project. So Rebecca, could you start by introducing yourself?
Hi, Tobias. I'm Rebecca. I'm a data scientist and Python programmer in Washington, D.C.
And Ben, how about yourself?
Hi guys, yeah, I'm Ben. I'm a computer scientist. I guess I'm also sometimes called a data scientist, but certainly more software engineering focused, and I also live in Washington, D.C.
And Rebecca, again, do you remember how you first got introduced to Python?
Yes, so I came to Python somewhat recently, so maybe 6 years ago after I had already finished graduate school, and I had a job, post-academic job, analyzing what was pretty messy data and looking for practical tools that I could use to sort of augment the research skills that I developed while I was doing my dissertation. I'd learned Maple in high school, and then in college some Java and some Perl. So I found Python just a really natural way to express my thoughts. And it was just when data science was starting to happen, and I was really excited to see all of the open source Python packages that were sort of rising up to meet that work. And it became clear that something sort of special about Python is that it felt like a really good way to build software and also build experiments. And then kind of starting to go to PyCon, I felt a real affinity for the Python community too.
And Ben, how about yourself? Do you remember how you got introduced to Python?
I do. I've been a software engineer for 12 years or so, I guess a really long time. And so when I started doing software development, it was a variety of systems and scripting languages like Java, C. And I remember that one of my first bosses introduced me to Python as a prototyping code for some embedded C projects that we were doing. So we would program in Python, and then once we had everything sorted out and tested and designed, we would re-implement that in C. But we quickly started using it for web development and system scripting. And as my job evolved, I started doing more cluster computing with Hadoop. And my job was focused on natural language processing, so dealing with large amounts of text. And so I found a lot of reasons to use Python with Hadoop, using Hadoop streaming and some other packages for NLP, and I was quite relieved when Spark came along and gave a full-on Python interface to that sort of distributed computing. So I've been using it for a long time, but I don't know if I started in the same place that many other people did.
And so the two of you have gotten involved in building and working with the Yellowbrick project. So I'm wondering if you can describe a bit about the use case for it and how the project got started.
Absolutely. So Yellowbrick is about visual diagnostics for machine learning. And where we see it fitting in is, how do you decide what's the best model or what are the right features? And there are sort of a host of mathematical tools for doing that. But, in my career and teaching, I've noticed that, you just can't stare at a bunch of numbers and really come to meaningful conclusions about progress. And so Yellowbrick entered as this way to see sort of more clearly how you were doing, where you were going, if you were going backwards or forwards during the machine learning workflow.
Ben and I met because I was enrolled in a data science certificate program that he was teaching for. And so he was actually my machine learning and software engineering teacher. And so some of this sort of just came out of the experience of me being a student and sort of talking to my teacher and trying to understand what was happening and wanting desperately to sort of understand as much as I could as quickly as possible and spin up that intuition, not sort of being satisfied to just sort of deploy scikit-learn without understanding what was really happening. And so this sort of, this came out of like a very close use case for me.
And so in order to be able to build these visualizations in a easy and somewhat automated fashion, you've hooked into scikit-learn and extended some of its capabilities and API. So I'm wondering if you can describe a bit about what's involved in creating these visualizations and what's actually involved in visualizing a machine learning model.
So, like you say, this is really modeled on the scikit-learn API, which, for folks who haven't explored it very deeply, it's really kind of an amazing thing. It represents sort of the consolidated research and domain expertise from a whole lot of machine learning practitioners and researchers, and it's all sort of coalesced under this unified API that makes it really kind of almost trivial to deploy and test any number of models. But kind of in order to visualize the models, you sort of have to have some understanding of that API and to know where to kind of hook in. So that in scikit-learn, there are estimators and transformers, and estimators have a fit method and a predict method, and transformers have a fit method and a transform method. And so, part of what you have to decide with visualization is sort of deciding, am I trying to visualize a model, a fit and predict kind of sequence, or am I trying to visualize a transformation? So, my data was this, and I performed some transformation, and now it is this other thing, and I'm trying to kind of visually compare. So, we kind of think about the machine learning workflow in terms of something called the model selection triple, which originally comes from a databases paper that we read 6 years ago now, that's sort of, trying to imagine what next generation databases will be like, ones that are sort of built to anticipate machine learning rather than just having machine learning sort of performed on them after the fact. And so the authors sort of talk about the model selection triple, which just turned out to be a really good way that we've found to describe how machine learning actually happens in practice. You've got these sort of, these phases where you have sort of a feature analysis, feature engineering phase, and then you move to a model selection, model comparison phase, and then into a hyperparameter tuning phase. And it's iterative, and you kind of go through cycles. But, part of really kind of leveraging the visualizations is figuring out, where to inject visualizations into that workflow.
And, I just want to add here, too, that workflow often looks like research code, where you have these sort of Jupyter notebooks just full of all this like matplotlib and maybe experimental stuff. And, that sort of annoyed me, I guess. It wasn't a very strong feeling, but it annoyed me as a software engineer that you didn't have repeatable, dry code, that you didn't have a mechanism for using these tools to actually see what you were doing. And so we really wanted to create a tool that got out of the way of the machine learning process, got out of the way of the model selection triple process, which I think is what most like visualization inside of a notebook does. It just is like this big block of code, and it really is. I mean, to generate a matplotlib visualization, you're talking about 15 lines of code at least for a simple visualization. And so with that in mind, we created Yellowbrick to map to scikit-learn's API. So we have this idea of a visualizer, which in itself is an estimator. So we like to think that visualizers learn from data in order to draw something, or to draw a visual interpretation of that data. And so they have the same API. They wrap other estimators, they wrap transformers, they are themselves transformers, can stick them into pipelines. And then in the end, using Yellowbrick is as simple as 3 lines of code, just the same 3 lines of code you'd use to do machine learning with scikit-learn, right? Import the visualizer, instantiate it, and then fit it or score it. Although we do have one special method called poof. So poof is our extra method that you have to call in order to actually make the visualization happen, to finalize it with, axes and setting the limits and titles and all of that sort of stuff.
And machine learning models have been typically very difficult to interpret and necessarily understand exactly what's happening, particularly when you get into deep learning and neural networks. So what kinds of information are you able to capture and convey in the visualizations, and how does that assist in creating an understanding of what's actually happening within that model?
It's funny you mentioned the thing about deep learning. I was going to say, I was reading on Twitter yesterday, and Neil Conway posted a really funny tweet. It was something like, anyone who wants to write an alarmist op-ed about the dangers of AI should be forced to spend 48 hours using TensorFlow to solve some non-trivial problem. I think that this work that we're doing is, a lot harder than, that it seems. It's not just hard to explain it. It's also hard to just kind of systematically go through the process. So in the context of Yellowbrick, if we're thinking about that workflow, that model selection triple workflow, in the beginning for feature analysis and feature engineering, you might use something like the parallel coordinates visualizer, or RADVIZ, the radial visualization, or something like Rank2D. In the case of parallel coordinates and RADVIZ, you can use those to look for class separability in your data, to see if the data are well suited for a classification. In the case of Rank2D, you might be looking for relationships, pairwise relationships between features, and potentially looking for things like covariance, or things that may complicate the modeling process downstream. For the model selection and model comparison phase, you might be using something like, if you're doing regression, you might be using a prediction error plot or a residuals plot to kind of inspect how effectively different regressors are fitting the data, and kind of where the error is happening. If you're noticing heteroscedasticity, distribution errors, those are very, very easy to see kind of quickly and intuitively with those kinds of plots. And then for the hyperparameter tuning phase, you might use something like validation curves to understand, as you introduce more training data, what's happening to the trade-off between bias and variance. Are you getting to overfit, at some point? Or you might use something like the alpha selection visualizer to see how well regularization is working. Maybe you're using like L1 regularization or L2 regularization to smooth out your data ahead of, some linear model. And you're kind of wondering if that, is actually working, if it is kind of helping to reduce that noise. But generally, kind of for all of the visualizations in Yellowbrick, we're aiming to kind of expose as much information as possible. So in the same way that scikit-learn really provides a lot of access to model attributes, we're trying to do the same thing, make sure that you have access to the scores, the timings for how long it took to fit or transform, annotations and those kinds of things to make sure we're conveying as much information as possible.
And can you dig a bit more into how the visualizations will assist in gaining understanding about what's happening within the various models that people are experimenting with?
Yeah, so this is a place that we really think that Yellowbrick shines, and that's this idea of steering or visual steering of the model selection process. The term steering itself comes from the HPC world, or the high performance computing world. And if you rephrase the model selection triple in terms of a search problem, right, what is the best combination of features, algorithm, data, and hyperparameters that leads to a model that's operational, something that we can use in our systems to actually make decisions. If you phrase it that way, you see that you're in a really just massive search space. There's a lot of different options, and that's actually the benefit of machine learning, right? I think one of the joys of having generalized machine learning frameworks like scikit-learn available and so easily accessible by a wide variety of people is that they can combine these models and data without necessarily having a PhD or a deep understanding. They can engage in the search process to find novel and unique occurrences of good fits. And if you're doing that on purpose, that can be very daunting, right? Where do you look? Where do you go? How do you correct your course if you're sort of heading down a wrong path? Or should we be using a probabilistic method or a Bayesian method? Is that most well suited for this? Should we go down a completely different path and use something non-parametric like gradient boosting or random forest? And I think that's what Yellowbrick is designed to do in terms of understanding the models itself, trying to compare two different visualizations of the same model, tweak it experimentally, and then you can see what changes happen in the visualization. So it turns out not to be maybe an interpretation of a single visualization, although that's very common once you get to that good search space. Once you start honing in on it, you might start to think, okay, well, what does this mean? How do I interpret the behavior of this model in this data? Do I trust this data? What amount of risk do I take on? But in the initial stages, it's really about comparing different models, comparing different instantiations of these triples, and looking for progress as you're making these changes and moving forward. That is certainly my experience of machine learning and using Yellowbrick in a couple of different projects and contexts. And as I talk to more data scientists, more people who are doing machine learning on a daily basis, I think that they're really starting to buy into this idea of steering, to this idea of visual analytics, where there's a combination of sort of this human domain knowledge with this machine ability to generate models very rapidly. And how can you combine those things in a meaningful way to find the best model? And Yellowbrick is a start at that. It's certainly not a comprehensive tool for visual analytics, but it does provide that interpretability that I think is lacking from just simple reports or numeric scores.
So in a way, it helps with going through sort of a human scale Bayesian process where you're iterating on your priors to gain direction in terms of where to go next to be able to come to an effective outcome.
Yeah, that's absolutely a great metaphor for it. What do you understand about what you were doing before, and how does that affect what happens after? And importantly, it also informs your team, right? It's a good way of saying, here's where I came from and here's where I ended up, and now you can take the baton and go from there as well. So I think the Bayesian metaphor is very apropos.
And in a way, the visualizations also can help to serve as documentation of your process so that when you're going back later to try and understand what it is that you were doing, you have some way of quickly being able to scan through and say, oh, these are the things that I attempted. This is where I ended up, and then not have to re-explore some of that space. And also for somebody else who's coming into the project, they have that same benefit of being able to just scan through the visualizations and say, these are the models that were attempted. This is why they went one direction or the other.
Yeah, absolutely. It's absolutely critical for me personally. I constantly think about future me and what's future me going to think about what I'm doing right now, and having that documentation, having that trail, having that sort of very quick getting up to speed with an experimental process, and also understanding failure. To a certain extent, right? A lot of times if you think about this experimental process, you're going to fail a lot. And Yellowbrick this Yellowbrick visualization serves as documentation to the failure so that you can sort of quickly go back and build from that base and sort of figure out what went wrong and why without having to maybe retread a rocky path. Absolutely.
And is there any way to easily co-locate some of the parameters that were used along with the visualization that was produced so that you don't necessarily have to retain all of the intermediate code, but be able to just quickly see, okay, it was this model, these hyperparameters, and this was the outcome?
So the answer to that is no, there's not an easy way to do that. If you want to test yourself a little bit, if you take a scikit-learn model and do get params on it and you try to JSON encode that thing, you will find that is a nightmare. And it's very difficult to do because you have all of these data types that can't be serialized, and it's nested, and there's references and objects, and it's kind of a mess. And that's one of the reasons, Rebecca mentioned that we try to include as much information as possible in the visualizations. We want to make them as rich as possible. And part of that is for that self-documenting reason, right? What parameters were in this model? For example, all of our titles usually have the name of the estimator in the title, just so at least you have that. For me personally, though, I do have to do a little bit of extra work to coordinate. I end up pickling my estimators even, and I just have like this directories full of a mess of pickled estimators, trying to coordinate them with visualizers, usually in the form of like markdown files and things. That's definitely something we'd like to see Yellowbrick do better at. Maybe include meta information in the image itself. And it's definitely on the list of ideas as we're trying to explore how to coordinate this workflow a little bit better.
Or possibly even in some of the EXIF data so that it's not necessarily immediately visible, but you can still extract it from the image and co-locate the data.
That's not a bad idea.
And visualizations can be difficult to get right in terms of figuring out what style of visualization to use, color scales, labeling, how big to make the image, etc. The distribution of the axes as far as how many units to display. So does Yellowbrick provide any assistance in terms of automatically selecting some of those settings or providing guidance on what types of visualizations to use for different types of models or different use cases?
Yeah, that's a good question. So Yellowbrick doesn't do a lot stylistically. I think that if we have a guiding motivation, it's for correct interpretation all the time. One example of this is we had a contributor say to us, this sort of looks strange, this figure, it looks like a little bit warped. And what we realized is we had a 45-degree line, but we didn't have a square image. And so even though it was a 45-degree line, it looked like it was, at a weird slope. And so, for us, it's all about correctness more than anything else. Although, we do tend to use like seaborn styles and things to make it look pretty. And, Matplotlib 2.0 is actually very good looking, but we definitely focus on maybe the utility of the visualizers.
And for somebody who is just getting started with Yellowbrick and starting with a greenfield project, what would the workflow look like for getting started and iterating through using Yellowbrick in that process?
So that's a really good question. I think that, we've been really focused on kind of building up a base of contributors over the last couple of years. And one of the things that we're sort of excited to do, this coming year is to kind of get a better sense of the users. And kind of ideally what we'd like to do is sort of capture the workflows of professional practitioners and try to encapsulate some of that, and map some of that onto Yellowbrick to make it as sort of natural as possible to do what they're already doing. We conducted like a kind of preliminary usability study last year, but we're looking to launch something kind of more formal in the next couple of months. So something that includes, user interviews with people who've been doing this for a while and maybe focus groups and A/B testing. But for the most part, we're most frequently kind of talking to students about the, building data science products and, working on data science projects. And so in a lot of cases for them, the questions that they're asking are things like, which features do I use and which model do I use? Which model is best? And we always tell them, just try them all and compare them visually and then try to, use those visualizations to understand why they're performing differently. They frequently we get asked, why isn't my model working? And it's usually something like a class imbalance problem or, strangely distributed data, like really sparse data. But those are things that you can visualize very quickly with Yellowbrick. But I think like for students, the main thing that we try to communicate is that, whatever your specific, kind of specific use cases, specific workflow is, that it's important that it's not a random walk, that your pipeline needs to be purposeful. It can be, cyclic and iterative, but those iterations need to be associated with hypotheses. You need to be, kind of thinking about hypothesis-driven development, conducting experiments, and, recording. And as you guys were just talking about documentation. Documentation is really important so you can, understand and compare your results. But, the flip side is that you need to be able to move quickly. So if you're doing a data science project for a class, it's due. If you're doing it for work, the client is expecting it. So there's no time to write out, 30 lines of custom code each time, or worse, to, export the results of your modeling and then try to visualize them in some, proprietary tool. So even though, Python isn't always students go to for visualization. We really emphasize Matplotlib and Yellowbrick because, being able to do everything in Python using open source tools really reduces the entropy and makes that workflow more smooth and iterative so that you can do better science.
And, just along those lines, I can at least tell two stories of how maybe Yellowbrick is used. What we're finding is there's a lot of different ways, like Rebecca said, and there's a lot of different workflows. But, maybe just more specifically, if it's interesting, I had a project, it was a regression-based project, and I was sort of coming from the world where I was very used to the modeling effort taking a lot of time, big classifiers or training big neural models or something like that. And so, but this new regression project, I maybe had only 5,000 instances and I was building about 30 models at a time for these different segments that I was trying to investigate, and they were trained sort of near instantly. And so in that type of scenario and that type of workflow, I was using Yellowbrick to really manage visually the changes between not just all of these sort of individual models, but then the aggregate model as a whole to get a better sense of, these sort of very small changes that I would make. Did they have a large impact? Did they have a big impact? And try to categorize them just from this broad level, like what was the impact? Using things like prediction error or the residuals chart. And, it's actually amazing. Like once you've run enough of these things, like you actually get a intuition. You get a sense just by comparing, training and test data residuals. You can really start to feel like, am I overfitting my model? Am I underfitting my model? Do I need to make my model more complex? Do I need to reduce the complexity of my model? And it's sort of hard to describe in words, because it is a visual tool. You need to sort of see it. You sort of see these patterns emerge. Whether it's areas of very high density in the residuals, whether it's along sort of one part of the target. You'll notice that different models have different shapes. So the parametric models often have very hard lines in the residuals, and you can sort of see stratification. Same with ensemble models. Ensemble models will partition different parts of the target, and you can sort of see if one part of your ensemble is weaker than another part of your ensemble, what the effect of trained test splits and cross-validation has. I really wish I could explain this. I mean, it would be better to show, obviously, this kind of thing, but you start to get that intuition. You can start to get this feel like, oh, I'm going in the right direction, or no, I'm not going in the right direction. And once you start to hone in, you might be using just a handful of Yellowbrick tools. Like I was just using prediction error in the residuals plot, but once I started to hone in, then I sort of came back and started doing these, deeper feature analyses with rank 2D. Do I have covariance? Do I have different correlations between my features? Are these things affecting my regularization decisions inside of these larger models? And once you start to explore it, one thing that I found was you start to get maybe a deeper understanding of the underlying data, and you start to maybe get that intuition or that sense of what the models are doing, and particularly different model families. Like how are they interacting with your data? And it's very specific. I don't know if I could take the intuition I gained in that project and apply it to a different regression, but in that project itself, things were very clear for me, and I was able to sort of tell, my teammates, this is what I'm seeing, this is what I'm thinking based on these results, and they would look at it and they would sort of start to develop that intuition too, even though they weren't in the thick of it during the entire process. I think it's almost like every unique ML exercise ends up with a sort of unique Yellowbrick or visual experience. And I'm hoping it's cumulative, that as you go on to more projects, that intuition, becomes more nuanced so that you can see what you're doing and what impact it has.
And in your experience, are there any other tools in either Python or other language environments that provide any sort of similar experience of being able to have this visually iterative cycle of building and testing these machine learning models, or do you find that it's largely unique within the problem domain of data science?
Yellowbrick is such a domain-specific thing. It's really tied to machine learning. There is another library that is a competitor of ours, I guess, that has sort of a similar thing. But I will say that when you're using Seaborn for exploratory data analysis, I think that I get it's different, but I maybe have that same experience experience of, I'm understanding the data in a deeper way, understanding distributions, and the visualizations that Seaborn's producing are enhancing my understanding of the underlying data. And I mean, it's completely different, right? That's for exploratory data analysis. That's for answering questions, with your data. It's not about machine learning. But I could see how that would be a similar experience in Seaborn for someone who's doing machine learning with Yellowbrick.
And you mentioned a bit about how Yellowbrick wraps these estimators and transformers in scikit-learn, but I'm wondering if you can discuss a bit more about the details of how it's constructed and how the design of the library has changed and evolved over the lifetime of the project.
Sure. So, kind of in the same way that scikit-learn has, estimators and transformers, Yellowbrick has tools that are specifically kind of anticipating some kind of scoring, so in the case of, modeling, they're sort of anticipating that you have a machine learning model that's being fit and that you can use the training and test data, for example, to score how well the model performed. So it's sort of hooking into the estimator part of the API there. And, there's other visualizers that are more kind of anticipating, data transformations. So one of the ones that I like a lot is the frequency distribution visualizer, which I use a lot because I work a whole lot with text data. And so a lot of times it's, for me, a way to visualize how the corpus sort of is changed or transformed as I perform sort of different kind of operations on it, like stop words removal or certain kinds of, key phrase or n-gram analysis. But in terms of how it's changed over time, I think that we're lucky because we were basing it on a very, very well-established API. The scikit-learn API kind of was, gave us, a really good design to begin with. But I will say, we've had a lot of contributors. We have, I think, maybe 35, maybe 40 contributors now. And every time somebody contributes something, the project changes a little bit. Everybody kind of injects some sort of, creative thing that changes things a little bit. But probably, from now on out, it's mostly going to be about adding polish and adding new visualizers that sort of capture the best practices that are being used sort of already by folks, but, who are doing it kind of manually and want to be able to do it a little bit more easily. I think, the steps, the sort of the journey that we took was kind of first sort of hardening the API, and then, every time matplotlib or scikit-learn changes, we have to, we sort of have to be prepared to keep up with those changes and provide, compatibility. But kind of one of the more interesting things recently is that we had to figure out how to do unit testing for plots. So the visual tests was tricky, and that was something that, we hadn't really thought about from the beginning, and then had to kind of retroactively implement for all of the visualizers that we had created. Luckily, we have a core contributor, Nathan, who really dug in his heels and, rolled up his sleeves, and he figured out how to do the visual tests, and he sort of set the model for how we'll all do that moving forward.
And currently, Yellowbrick is tied to Matplotlib for doing the visualizations, but do you foresee adding in support for any other visualization tool chains, or is it sort of hard-coded to Matplotlib, and that's just going to be your main focus going forward?
That's sort of a topic of a lot of debate. I mean, certainly we get a lot of advantage from using Matplotlib directly, and I will say that it does play well with other libraries that are also Matplotlib focused, so Seaborn, if you change the styles, I constantly use Seaborn and Yellowbrick side by side. One of the questions I'm constantly asked is, can you modify or manipulate the visualization? And the answer is yes. You can access the axes on the visualizer and use any sort of tool that Matplotlib tool associated with it. And so I think that there's a few new libraries that are coming out to try to extend Matplotlib into other domains and web domains and things like that. And so if people do that, then Yellowbrick will also be able to take advantage of those things. However, I will say that we're not against other visualization libraries, and we just started a contrib module to sort of try to think about these things formally. For example, another one of our contributors, Craig, just recently wrote a blog post on districtdatalabs.com where he talks about using R and Python along with matplotlib and how to sort of coordinate these things. And his post is actually really interesting. It's on bias and fairness inside of algorithms. So we don't think that it necessarily has to be mutually exclusive, but when I look at sort of the visualization landscape, to me, it's either something like matplotlib where you're rendering sort of raster images, and there is a little bit of interactivity inside of a notebook that you can add to matplotlib. But then the other side of things is tools for visualizing inside of a web application, something like Shiny or Bokeh or something like that. And we do ask ourselves that question, would Yellowbrick work well inside of a web context? And we're not sure, because Yellowbrick is sort of a single seat user kind of tool, right? It's not meant for a general audience. It's meant specifically for the data scientist who's in the chair, who's actually working and interacting with the modeling process, and then for that person to communicate their discoveries. I don't know if you made a Yellowbrick visualization just globally available on a website, whether or not that would be meaningful or interpretable without all the sort of sweat equity that goes into developing that intuition. That said, we do have this feeling that interactivity is going to become a very big part of Yellowbrick in the future. Yellowbrick has sort of at its heart is a high dimensional visualization tool. And I like to say there's really only 6 visual dimensions that you can encode, size, color, shape, all these kinds of things. And time is sort of the 7th, right? If we can have a slider where we can drag things, or if we can, do this sort of meaningful interaction where we have an overview first and zoom and filter, get details in demand, we think that provides sort of a richer visual experience. And so, like I said when I started, this is sort of a question. Is matplotlib gonna take us to that place of interactivity? Are we going to have to look at other tools that are maybe more web driven? Is there a happy medium? We're not 100% sure. Although there could be, maybe there'd be a fork, Yellowbrick Web or something like that, and we'd be very interested in seeing tools like that.
And what about any other machine learning frameworks? Have you looked at the possibilities of integrating with things like TensorFlow or Keras or any of the others in the ecosystem?
And actually that is the whole reason that the contrib module exists, actually, is for that reason, until we sort of thought about formally engaging in other things. So stats models was the first, where we had a contributor say, hey, I want to use stats models. There's nothing stopping me from using stats models except that I have to, create an API, like a scikit-learn API or a wrapper for this thing. And so they did. Right? They created this sort of fake estimator where, it used stats models under the hood, and the visualizations worked off the bat. Craig, whose post we mentioned before, he actually had historical data, and so he created something called the identity estimator that just acted like a scikit-learn estimator, but fed information from a file on disk, and that was able to allow him to create, the classification reports, ROC-OC curves and threshold things, to actually use the Yellowbrick visualizer. And so at PyCon, actually, several of us had a big discussion. Well, how can we open this up beyond scikit-learn? And Keras has a scikit-learn interface. We suspect that it would not be that difficult to include that. The question is really not if, but when, and how do we hook into these things? Is it going to have to hook in from some sort of underlying pickle? How do we sort of distinguish Yellowbrick from something like TensorBoard? How do we provide sort of a meaningful augmentation to the tools that already exist for things like TensorFlow and Keras and PyTorch and things like that? So there is a path in place. Yellowbrick is at 07 right now. I don't think that there might be some initial prototyping of that kind of tooling in 08, but I would say that definitely around 09, whose time frame is about the end of this year, then we're going to start to see some significant support for Keras, at least, moving forward.
And what have been some of the most challenging or unexpected aspects of building and maintaining and growing Yellowbrick in its community?
Originally, when we started out working on it, it was just me and Ben, and at that point, it was kind of surprisingly easy to just kind of prototype out, a single visualizer from beginning to end. Now that is, a little less straightforward. The idea part, the prototype is, still kind of fun and exciting. And then there's sort of the work of writing the tests and the visual tests and doing the documentation and all of that. And it's one of the things that we do think about. We want to make sure that people feel like they can contribute and enjoy the sort of the fun part and not feel kind of too burdened by the rest of it. So we offer, a significant amount of support to contributors, to kind of get them to the finish line. And so one of the things that we work really hard at is striking the right tone in the dialogue of our issues and with pull requests and code reviews, even with each other. If it's just core contributors communicating with each other, those things are visible to everybody. And it's important to set the right tone so that people know that we're welcoming and, we're all excited and we respect each other and admire each other and, are interested in other people's sort of creative ideas for implementation. Some of the challenging things are support for platforms, especially Windows, has been a little challenging. I guess we'll all see what happens now with the GitHub kind of being bought. Potentially we're looking forward to a future of, slightly less challenges, potentially looking for silver linings there. Python 2.7 support is an ongoing struggle. We just kind of put out a survey to the users, our community of users, asking whether or not they might be open to not having 2.7 support anymore because it is kind of a pain in the neck.
And in the process of working with Yellowbrick, what have you found to be some of the limitations or edge cases that it doesn't cover yet, or that you possibly don't intend to have it cover?
So yeah, this is a great question. One of the things that is most striking, perhaps, is the fact that Yellowbrick has a smaller data cap than scikit-learn does. You can only draw so many things. And, whereas scikit-learn is implemented with a lot of C support, Yellowbrick is mostly pure Python. So performance can also become a very, real issue, especially if you're trying to deeply integrate Yellowbrick with, scikit-learn using pipelines or some other toolkit. So, we recently had this with parallel coordinates. We noticed that parallel coordinates was getting slower, and we didn't really know why. We just knew that we had these sort of benchmarks that were just, starting to crawl. And we knew that we couldn't let that affect the machine learning process, right? We want these visualizations to be an aid, not something that you have to do and not something that gets in the way of the process. And so, our first tack at that was coming from the approach of this, data cap. Well, maybe we can add in some sampling, right? And just, take a uniform random sample or a stratified sample of the instances and only display those things. And that definitely eased the problem, and it wasn't a 100% solution. One thing that did come of that is we noticed that you can actually use different sampling methods and compare different sampling methods, and there's sort of like an idea for an interactive type thing that's sort of similar to brushing in parallel coordinates. But as we dug deeper into the problem, we started realizing, and this is one of our contributors, Kyle at PyCon, sort of noticed this. We're visualizing or we're drawing, one thing at a time, which means that as you add more data, the slower this thing is going to become. So instead of drawing everything one at a time, every instance one at a time, why don't we just draw the class as a whole and insert nans, in the middle so that the lines looked correct? And boy, Heidi, Kyle's implementation was something like 245 times faster. We went from, 30-second fit times down into the millisecond range. We were just stunned by how fast this new implementation was, and we start to think to ourselves, oh man, are we, what have we been doing, or are we really, do we need to review all of our visualizations and make sure that we're not doing things? But as we continued through this process, we realized, actually this comes at a cost. When you're drawing an instance at a time and you're giving them an opacity, these sort of, the opacity is additive one instance at a time, and you can start to see these dense braids of instances, which is what you're looking for, right? You're looking for clusters or groupings or any sort of coordination across features, and you're looking for those braids. And that only happens, the additive opacity thing only happens in the drawing one instance at a time, and it does not happen when you draw a class at a time. And instead, you only get that sort of darkening effect between classes. So, in the end, we said, okay, well, I guess we'll provide both of these options. So there's like a fast parallel coordinates and a regular parallel coordinates, I guess. So they allow the user to choose how they want to tackle this visualization problem. But that is certainly a challenge that we're going to continue to face. Visualization just has limitations, both in terms of time and in terms of space that you have on the image. More and more, we've been trying to ensure that the underlying implementations are using NumPy, that we're taking advantage of NumPy's performance wherever possible. We try to avoid Python objects where we can, especially since we're in that SciPy world. Just ensure that we're sort of following the same types of steps. But this also leads to this sort of other interesting problem, and that's when either, we sit on top of both Matplotlib and scikit-learn, and when either of them chokes, like raises an exception, that bubbles up through Yellowbrick, and you get these very unintelligible tracebacks. Bug finding becomes an issue, and so, if there's one thing I want to say, these limitations are certainly there. But the fact that they aren't as noticeable is because of the extremely hard work of our contributors to go and find these things and capture exceptions and write better traceback messages and give advice on the documentation of how to handle things. It really has been impressive with how much work they're doing. In the end, the biggest thing is that, in terms of edge cases, visual meaning depends on the data and the model that you're using. And the edge case, I think, is possibly disappointment. So this is something maybe I feel a lot more, maybe than other people. So one of the new visualizers I just recently implemented was a manifold visualizer using tsne or isomaps or other embedding techniques to try to do an embedding instead of a projection of high-dimensional space into two-dimensional space. And I thought, oh man, this is going to be great. This is going to provide a lot of functionality, and you're going to be able to see a lot of different groupings, and it's going to be a tool that's going to be widely used. And those tools are performance intensive, and they can take hundreds of seconds to fit and draw. And the first real world quote unquote data set that I tried this on, I ended up with like 1 point, like it had just embedded everything right on top of each other. And so, it was just the data I had, it was just, the tools I had available. And so I think that's maybe the biggest, I don't know if you call that an edge case, but the sort of biggest limitation is both, your data and your model and what that ends up being in terms of a visualization, because it will be unique. It will be a different experience.
And looking forward, what are some of the things that you have planned for the future of Yellowbrick?
So we're really interested in kind of capturing more users and, figuring out more of the domain practices that are already being used that we can create, visualizers with, hopefully in collaboration with those, practitioners that correspond to use cases beyond the ones that we're the most familiar with. Machine learning is a really big space. It gets used in a lot of different disciplines, and there's a lot that, I'm sure is out there that people are, kind of doing manually now that would be, and that's sort of, that's what makes scikit-learn so great. It sort of became this place where all of these different practitioners came to contribute. So we would really like to have something like that in Yellowbrick. And so we're hoping that we can get more people to find the project, on GitHub and star it and check out the docs, reach out to us through the issues and kind of share their ideas or share case studies from things that they're working on, so we can get kind of a sense of what else we could be doing.
And then from the feature side, we're looking at doing visual optimizations. I think that's kind of the next big thing for me. Thinking about how can we minimize, maximize, white space, opacity, overlap. How can we actually use the sort of modeling process instead of the visualizations themselves? A lot of the visualizations depend on the order of the features or the order that you draw things. And so can we apply maybe a more rigorous method in selecting the best visualization, the best possible visualization for the model? This also leads to sort of another maybe thinner idea that we have, and that's, is there such thing as visual correlations? Something that exists inside the visual space that doesn't necessarily exist inside of the statistical space. So, one thing that we're thinking about is using voxel-based approaches where we sort of draw a voxel over any dimensional space that's been plotted by visualization, and we look at the density of the points or the lines or the drawing, the colors that are inside that space, and use that number as a representation of the goodness of that visualization compared to the goodness of another visualization. Coincidentally, that's more or less how we do the visual testing to see if a baseline image has changed from our test image. I mentioned this before, interactivity is certainly the next phase of features, along with the contrib library and Keras support and better stats model support. And then the last thing is better reports and organization. The one thing is, I've noticed that, you're never doing just one visualization per model. You usually have a handful or a deck of visualizations per model. And so the question is, how can we group these things together? Can we come up with, like a flipbook model? So, like inside of a notebook, you can flip through the visualizations one at a time. Is a visual grid better, where we just create sort of a report and create a grid? Should we be creating, HTML templates with Jinja, where we're writing base64 encoded images into an HTML file that you can open up inside of a web browser? Maybe something kind of similar to TensorBoard, but more Yellowbrick focused. So those are the types of features that we're thinking about as we're moving forward.
And beyond visualization, what are some of the other areas that you would like to see innovation or additional tooling come forth in terms of how data science is taught or conducted to make it more accessible and understandable for more people?
So one of the things that I observe is that, in practice, I'm seeing data science sort of being used in one of two ways. So one as sort of business analytics 2.0, so where data scientists, are maybe in some kind of standalone office in their organization, and their job is to, use machine learning, use visualization, do analysis that kind of goes into some sort of business reporting that goes to management, and then, decisions are sort of made based on that. And then the other model is where data scientists, occupy maybe a somewhat less glamorous position, but are actually embedded in the engineering team. So they are building features that kind of just go into the software, integrated into the software. And, as somebody who's more kind of on the second, in the second category, I think that one of the biggest challenges that I face, and I think Ben would agree with this, is that a lot of the problems you face are sort of more mundane. It's not like, is my model working, or like, what's the best TensorFlow architecture to eke out, the most performance, but things like, how does experimentation that I do fit into the agile workflow? Or how do I get, these back-end developers who don't know very much about machine learning to approve my pull requests so that I can actually get my stuff integrated into the software? Because ultimately, the machine learning stuff is really unpredictable, and it comes with uncertainty and risk from a corporate perspective. And we haven't really totally figured out as a community how to work effectively inside that sort of development environment. But my sense is that the skills that really need to be taught to data scientists kind of as we move forward into, the next generation of data products is really software development skills. So things like testing and configuration management, security, microservice architecture, so that you know how to actually deploy the stuff that you're building. We're also sort of looking forward to a new generation of project managers, product managers who are really, more savvy about data product construction, so that they can really help mitigate the risk and kind of plan around it and support data science development throughout kind of that model selection triple workflow that we talked about.
And are there any other aspects of Yellowbrick or any other things that we touched on today that you think we should discuss further before we start to close out the show?
I mean, we definitely want to hear from Yellowbrick users. I'd say that's the number one thing. We have a lot of stories that we can tell about Yellowbrick and how it's used. I think you've heard a lot of them, both from the user side and the development side. It's been a very important project to both Rebecca and I, and we want to make that project more widely used. And to do that, we want to incorporate feedback from others so that we know how to sort of what features are most meaningful and how we can make the library as general as possible.
And so with that, I'll have you each add your preferred contact information to the show notes. And I'll thank you both for taking the time to join me today and discuss the work that you're doing with Yellowbrick. It's definitely a very interesting project and one that seems like it's providing a lot of value. So thank you for that. And I hope you enjoy the rest of your day.
Hey, thank you so much for having us.